The author is Dr. Yoshihiro Banchi. Yoshihiro Banchi received his doctorate from Waseda University 2020, and he is an assistant professor in the School of Fundamental Science and Engineering of Waseda University.
Good morning or good evening. I'm Yoshihiro Banchi from Waseda University. I'm talking titled in evaluating user experience of different angle VR images. In recent years, VR is widespread in the world. In particular, VR images are contributed via some platforms with various VR format. Main VR formats are the VR 180 in stereoscopic and 360 video in both mono and stereoscopic. The format is selected according to the content, such as VR 180 for roller coasters and 360 video for landscapes and sightseeing. In our previous study, the effect of the VR format was examined. The four conditions were set in 180 or 360 degrees and 2D or 3D, and evaluated the user experience. From the result of this study, angle and stereoscopy affected the user experience and indicated the synergetic effect of them. And viewing behavior was different between 180 and 360 degree images. In the previous study, user experience was influenced by different VR formats, and in user experience, 2D 180 was the lowest, followed by 3D 180 and 2D 360 to the same extent, and 3D 360 was the highest. So, the question, does VR really needs 3D and 360 degrees? One of the problems with a VR image is that editing stitches are very costly. So, if user experience were the same at 3D and 350 degree and 360 degree, the stitching would be much easier. So in this study, it is experimentally examined how angles needed in VR images. We set 2 images and 7 angle conditions. Images were shot in Insta360 Pro, which is a 360-degree stereoscopic camera. The difference between the image is the room size, and angle conditions are every 30 degrees from 180 to 360 degrees. This is a 180-degree stimulus image. The back half is masked in black. Also, the border with the mask is blurred like YouTube. Next is a 270-degree stimulus image. It is masked with black 90-degree behind. Next is 360-degree stimulus image. You can see all angles. Evaluations were obtained with subjective and objective indices. As a subjective index, the rating 7-scale questionnaire was taken. The evaluation items were reality, presence, depth sensation, and they were from the previous study on the evaluation of 3D images. As objective indices, head and gaze movement were measured. The gaze movement indicates what you are watching in the VR space, like this heatmap image. About the layout of the experiment, Toby-Pro VR integration based on HTC Vive was used, and it can measure a gaze movement, and participants sat on a swiveling seat or the headset without headphones. The participants were 19 university students. First of all, the purpose and method of the experiment were explained, and the consent was gained. The procedure was participants gazed at a calibration marker for gaze tracking, and then they watched each image for 30 seconds. After that, they answered the questionnaire and got rest time. Considering the possible influence of viewing order, the image presentation order was randomized. This is the result of the questionnaire on reality. The vertical axis is the average score, and the horizontal axis is about the conditions. The blue bar is on image A, while orange one is on image B. It seems that the score increases from 180 to 70 degrees, and the score between 270 to 330 degrees is evaluated similarly, and 360 degree was highest. On a two-way ANOVA, it was found to be significant effects of angle. This is the result of the questionnaire on presence. It is like the result of reality, and that score increases from 180 to 240 degrees. The score between 240 to 360 degrees is evaluated similarly, and 360 degree was highest. On a two-way ANOVA, it found to be significant effects of angle and stimulus. This is the result of the objective indices of gaze movement, horizontal distribution by kernel density estimation of gaze tracking data. The vertical axis higher means the straight time is longer, and the horizontal axis about the direction angle. Focusing on around the back near 180 degrees, the ratio of 360 and 330 degree images were larger than of others. This is a result of the objective indices of head movement. It is like the results of gaze movement, but in the 330-degree image, the difference is not so clear compared to the gaze movement. As a result of reality, the score increases from 180 to 270 degrees, and as a result of the presence, the score increases from 180 to 240 degrees. This shows the angle improves user experience up to a certain angle, and 270 degrees is considered to be an angle that can be easily looked around by the interaction between the range of body motion and the field of view. So in more image angles within a range of easy to see, user experience improves. As a result of reality and presence, the highest score is in a 360-degree image. This shows the black mask has a big impact on the user experience. From the results of the objective indices, viewing behavior changed at 360 and 330-degree images. In the lower 300-degree images, the black mask covered half of the field of view looking at the border, but at 330 degrees, it can see the image on the other side when looking around the border. So viewing behavior may be distracted by black covering more than half of the field of view. This means half of field of view determines the viewing behavior. In this research, we have examined the user experience on different angles of VR images. From the result, 3D and 360-degree images are important in VR. Why is it so? From the result of reality and presence, the score increases from 180 to 270 degrees, and between 270 to 330 degrees evaluated similarly. This indicated that user experience is improved up to about 270 degrees, and the 360-degree image is the highest score. So that shows the user experience is very different between 360-degree and others. From the result of objective indices, the black masks affected the viewing behavior, and the viewing behavior is different at 330 and 360-degree images from others. This indicated that viewing behavior is restrained by covering black masks with borderline. These are regarded as a useful characteristic of user experience for VR content creation. So that's all. Thank you for your kind attention.